Hi, in this video, we want to take a look at creating Choropleth maps with Leaflet in R. Okay, so Leaflet is a really common, really powerful way to make maps, using data. What we want to do, we want to grab that Leaflet framework, pull it into R, but wait, there's more, because what I want to do, I'm going to have geographic regions, and I want to connect those regions with data that I have. So I've got a base map. I have polygons for mapping on that base map. And then on top of that, I'm going to take data and I'm going to connect that data to those polygons. All right, that's our game plan. That's our goal. Okay, so what we're going to do in this Choropleth map, we're going to color our regions using data values. So something I could do, I could color, think about the standard map of the United States with the 50 states. I could color each map, or I could color each state by the population size, or I could go by population density. I could color each map by the number of COVID cases. I could color each map by which year it came into the union. There's a whole bunch of options. Okay, so what we're going to do, we're going to take some data from Pasco County Public Schools. So here's the website. Thank you, Pasco County Public Schools. Thank you for giving this. This is on their GIS part of their data of their website, where also you can look at maps of where their schools are. All right, so I download the data from here, and I'm going to load it. All right, so this is going to be a shapefile .shp, and we're going to be looking at elementary schools. All right, so in general, most of the time when we're talking about school zones, there's usually more elementary schools than middle schools, more middle schools than high schools. So to make it more interesting, I went ahead and went with the elementary schools. Okay, so I could also have done this with their middle schools. I could do this with their high schools. I could do this with their charter schools. Now, to read this shapefile, there's a couple of choices I have in R to work with. I chose for this situation to use RGDAL read OGR. It works really well. I find that if I don't know how to read a file that has geospatial data, usually RGDAL is a good choice to go with. All right, so now when I pull this in, what's going to end up happening is that it's going to give me a shapefile, and it gives me some input. We can see that there are 48 features. That's telling me how many polygons I have, and 3 fields. Okay, so now how this is set up, as I've read this in, this is going to be contained in R as a spatial polygons data frame. Okay, so I have a data frame and I have polygons that are geospatial boundaries, and I need to keep those connected. All right, so how R does this is that the order of the rows in my data frame correspond to the order of my polygons. So if I switch the order on one of the two and don't switch it in the same way on the other ones, everything's going to get screwed up. Okay, so what I have to do is I have to make sure that the polygons stay in the order that they are originally. That's easy peasy. Now on my data frame, as I'm working through, as I'm doing my data prep for what I'm going to be working on, if I mix up the rows of my data frame, I'm going to mix up my entire data set, and things are I'm going to get junk output. I don't want that to happen. Okay, so how am I going to handle this? How am I going to make sure that I'm protected from producing junk? Well, what I'm going to do is on my data frame, I'm going to create a column called original order. So this is going to be 1 to the number of rows in my data sets. All right, so what I'm going to do is I'm going to create this new column, 1 to the number of rows that I have. I'm going to do merging, joining, whatever I want to do. And to make sure everything is in the correct order, the original order, I'm going to sort by this column right here. I find that this is an easy way to protect myself from changing things. Some of the functions like merge in R permutes the order of the rows, and so it gets them all jumbled up. If I need to preserve row order, just make a new column and call it, 1 to n. It's easy peasy lemon squeezy. Okay, now the next thing I have to worry about, if I go through and I attempt to plot this in Leaflet, things aren't going to make sense. All right, so the Pasco County Public Schools original data set used a different projection than the standard global projection that is used more commonly. It's a perfectly good projection. It's solid. It's good to work with, but Leaflet doesn't like it. All right, so either I need to change things in Leaflet or I need to change things in my spatial polygons data frame. I decided to change it in my spatial polygons data frame because I feel like that's the easier way to go. Oh, something I need to say. When I loaded the data, you'll notice I gave it this really long name. All right, something I like to do when I am naming the objects I'm working on, I go first, the structure of what it is I'm working with, then second, a description of what it is. I find that this is a very good practice so that 6 months from now, when I have to reuse some code, I can look, I know that this object is a spatial polygons data frame. That's a very descriptive name or descriptive description of what the object is. It tells me exactly what it is. I have no doubt of what the object structure is. And now this part tells me, it just basically gives me a name for the object I have. I strongly recommend that you do something similar when you're working on projects. All right, so now to convert, remember I have a not bad projection, but a projection that the Leaflet paradigm does not like. So if I want to know what is my projection, what I do, I go to my spatial polygons data frame. There are going to be 5 slots on there. First one is data, last one is the projection. Here is projection for string. And when I look at this, I can see that's a CRS argument. And this is information about the projection. Now, mathematically, I could work with this, but as is, I have to change either Leaflet or I have to change my spatial polygons data frame. I'm going to change the data frame. All right, so how do I do that? Well, it's easy peasy lemon squeezy in the SP package. So I'm going to take the SP package, SP transform, and what I do is I specify the projection I want. The WGS 84 projection is by far the most common one that I've found on the internet. So that's the one I prefer to use because it's so standard. Here, I just say what the object is that needs to be transformed. I call out the new projection, and boom, when I look at the output, I see that it's converted to what I want. Okay, so now let's take a look at a quick map just so that you get a better feel for what the goal of this video is. All right, so my goal is to create a map like this, but I want each school district to be colored by information I have for, not school list, each school zone. I want the school zone to be colored by data corresponding to the data, either school grades, or some aspect like that I'm interested in. So I just want to go through, I want to change the colors to match my data. Also, if you look at these colors, you notice that I have a bunch of green back here. Now, if I'm going to have transparency in my county colors, and I have a background of blue, I have a black background of green and so forth, that can change the perception of the data, which I don't like. So something I'm going to do, I'm going to change the background to be only black and white. Oh, and here's the code for how I got this map. I just took my data frame, I passed it to Leaflet, added tiles. So this is saying, hey, create the base map, the part underneath. And then this is plot the polygons. And I put the labels on here, just, quick and easy, so that I can double check to make sure everything is looking right. This is actually why I did it, to make, so in a moment when I make my colorful maps, I can check to see that this upper right-hand corner, the northeast corner, is this particular elementary school. All right. So now, just so we can look, I want to look at the data set that we have to work with. So this is the data set that came inside the data frame, or inside the spatial polygons data frame. So this is the actual data that is connected to the polygons. Now I want to pull in some data from the Florida Department of Education. And I chose to use the 2018-2019 school grades. Now, why did I choose this? Well, because of COVID, this is the most recent reliable school grades in the state of Florida. Now, right now it's 2021. The 2020-2021 school year did have school grades, but schools were able to opt out because of COVID. So it's not really a meaningful piece of information if I look at the school grades. And the year before that, the state of Florida did not have standardized testing. Therefore, there were no school grades because of COVID. So this 2018-2019 school year is the most recent reliable school grades that we can work with. So I chose this one. All right. And this is coming from the Florida Department of Education. And here is the website, for the accountability portion of FLDOE. All right, so what I'm going to do, just like in any other R project, I'm going to load my data. Here, the state saved it as an XLS file. So I chose to use read XLS in the read XL package. I find that this is a good choice for working with Excel data. I have everything stored as text initially. Why did I do that? All right, think about Social Security numbers. Some Social Security numbers start with a 0, right? Well, if R interprets Social Security numbers, which are all numeric values in that column, if it interprets that as a number instead of an ID, then what's going to happen is the computer is going to convert it to a numeric value, and it's going to drop those leading zeros. Okay, and so the computer is going to try and set it up so that it will be able to do addition, subtraction, stuff. That doesn't make sense. Here, if you look at the data that we're looking at, there are ID numbers that start with 0. In fact, a lot of them start with 0. And I don't want to lose those leading zeros. So what I personally like to do whenever I'm reading in data, I read in everything as a text value. And it's not a factor because R is a pain in the neck when it comes to factors. I read everything in as a text and I just leave it. And if I want to work with a particular column, then I will convert it over to numeric factor, whatever I need, but I start out with everything as character string. Now, next thing I do is I clean up the names, and the janitor make clean names function. What this does, this puts everything into case format, or it puts it into snake format. And I always do this just to have consistent column names. That's why I like using the janitor package. Now, next, if you look, so I'm looking at school grades across the entire state of Florida. I don't want the entire state of Florida. I just want Pasco County because that's all I have for my map. All right, so I'm going to filter out the schools that are not in Pasco County. And just to make it a little bit cleaner, I'm going to go ahead and filter out the schools that are not in my geospatial data frame. So here, I'm saying I only want schools that have a polygon for plotting. All right, so if you know a little bit of something about schools, not all of them have school zones. A lot of times charter schools don't have school zones. A lot of times alternative schools do not have school zones. Consequence units, special needs schools, these types of also magnet schools might not. A lot of different types of schools don't actually have school zones. So it doesn't make sense for me to try and plot those school zones. So I'm not even going to try. So here I'm only worried about the ones that have a school zone. Now, if I look through the data sets, the percent of total possible points is a numeric column. So it makes sense to use these as numbers. So I'm going to convert this to as numeric. And now I'm just going to look at the data that I want to tack on to my spatial data frame like that. All right, so here I want to look at the school number. So that's the ID number, the school's grade, and the percent of total possible points. All right, so let's go ahead and merge the data. So something about this, I'm using merge. Base R merge by default shuffles the order of my rows so that it's in order on the left data set, the one that's X, and it sorts it on those values on the ID numbers. Okay, so I'm going to take my spatial polygons data frame data. I'm going to take the school grades. I'm going to do a left join with cost center and school number matching up. I'm going to include all the data that's in my spatial polygons data frame because I want all the schools that have a polygon, even if it doesn't have school grade data. But I don't want all the schools, period, just because if it doesn't have a polygon, it's not useful for this project. And I don't want to sort because that could screw up the order of my rows. And I need to keep the order of my rows the same as when I open things up. Okay, so now what I'm going to do is I'm going to look for missing values. There are some missing values in the data set. So I'm going to take my data. I'm going to check each one's class. Then what I'm going to do is I'm going to put the word missing every single time I have a missing value. Rather than having a missing value of NA, when I have categorical data, I like to explicitly say missing and treat that like a level of data. I find that this is a better approach than the classic way of having a special format for missing. Now, when it's numeric, I just leave it as an NA. Okay, so here, I can see that I've got plenty of data going on. This goes on for a bit. Here's all the values. Like we can see, since we're talking about elementary school, college and career acceleration doesn't make sense. It'll be missing all the way through because that is a high school field. And we can go all the way down like that. Okay, so now what I'm going to do, I'm going to define the colors when I actually do my map. Okay, so what I want to do is for A, B, C, D, F, incomplete and missing, those are all of the school grades in my data set. I'm going to assign a color. So dark green for an A, green for a B, yellow for a C, red for a D, dark red for an F, and then if it's incomplete or missing, I'm just going to put in gray. Okay, I find that this is a good color palette for the purpose of communicating results. Dark green, so just like a stoplight, green is good, red is bad, yellow means you're close. All right, so dark green for really good, green for good, but could do better, Yellow for, hey, we're okay, but we're pushing it. Red is, yeah, okay, things are not where they need to be. Dark red means they really aren't where they're supposed to be. All right, so how I choose to do this in R is I create a vector of the colors that I want, and then I name the entries. I put the names for the vector to be the values connecting to them in my data set. Then what I do, here I take the values in my data sets, I pass it to index inside the vector, and then I define that as my new color column. I find that this works out really, really well in a lot of situations. It's a little bit more complicated for numeric data, but for categorical data, I feel like this is a good choice in most situations. All right, now something that I'm going to do is I'm going to go ahead and make the schools themselves, the school names, as a factor. And I'm going to order them by the percent of total possible points. And so I'm doing this so that I can create a visualization just so I can see some bar plots that I'll show you in a moment. All right, so here I'm taking the school names, and I am creating a new column called school name, and I am creating a factor with it. Now, the important part is that I'm putting in the order to correspond to the percent of total possible points right there. And I want to show you what that looks like. I'll explain this visualization in a moment. We'll go back up in a second. But now that I've done that, we can see that Trinity Elementary is a school that had the largest percentage of points, and Rodney B. Cox had the lowest. And we can see like a gradient as they go through. So the order corresponds to how well the school performed in terms of percent of total possible points. Now, that visualization is how I like to get colors for numeric data. Okay, I haven't really found a good way to get a numeric data connected to colors. I just haven't found like a good way in R to do that outside ggplot. So my trick is I don't fight it. I use ggplot and I grab the ggplot colors, easy peasy lemon squeezy. So what I'm going to do, this part here is creating that visualization we looked at a moment ago. All I really care about this is the colors for the bars and which school they connect to. So here's my trick. I'm going to take the school ID number, which is labeled as cost center. I'm going to include it inside here, right there. You notice that this is inside the AES statement. If you are familiar with ggplot, you'll notice that I've got X, Y, fill, label. All right, when I go through and I process, if you've worked with ggplot before, you'll know that there's going to be a build function there I can pull a data frame from that gives me all the information needed to plot the visualization that we just looked at. What I'm going to do is I'm going to include an extra column that I'm going to call cost center. And it's going to match the ID numbers from the data that I put in. All of this is just to get the visualization we want. The stuff that is important to us is I have a geom for column bars, like a bar plot, column plot, and that I have colors defined. So I could reduce this visualization to ggplot, AES, column plot, and then the colors. That's all I need. All the other stuff is just to make that visualization informative. It doesn't, it doesn't hurt anything to build up the full visualization, but it's not necessary. And here's that visualization again. Now, what I want to do, I want to grab the colors here and take that, put it inside my spatial polygons data frame so that I can use that in a moment. All right, so to do that, I take ggplot build. I take the plot we just looked at, which I called P. I grab the data, and every time I do this, I have to manually look to see where it is. All right, so in the plot call, I had geom calls and geom text. I wanted the bar plot colors, therefore, I wanted the first one. The first one I defined in the function call corresponds to 1. The second one, if I had 2, that would correspond to the text. And I want the cost center, so I have the ID number, and I want the fill, because that is the color of the bars. And I'm going to just merge it on to my spatial polygons data frame. All right. Now, remember, I have done 2 merge steps on my spatial polygons data frame. I've done it twice. That's 2 opportunities to screw up the order of my rows. How am I going to protect myself from this? Well, fortunately, earlier, I created a column called original order. I know that that's the order I want my data in if I want it to connect correctly to the polygons. So I'm going to go through, I'm going to reorder my rows by the original order. Boom, easy peasy lemon squeezy. Now, something that's important about this is that every step that I made, I did not lose or gain any rows. I have exactly the rows I want, no more, no less, and they correspond perfectly to the polygons in my spatial polygons data frame. So now let's look at the punchlines. We got 2 punchlines. I have a map where color is by grade, that's categorical data, and I have a map where color corresponds to total percent of points, which is numeric. So let's take a look. All right, so what I'm going to do, I'm going to take my spatial polygons data frame, I'm going to pipe it into leaflets. I'm going to say I want a black and white map as the base map, which is add provider tile stamen. I'm going to plot the polygons. Now you'll notice that the color corresponds to school grades. Here I'm putting on a label of the school name and then the grade they got, percent of total points. I'm going to make it at 80% opacity. Now, if I put a 1, I won't be able to see through it at all. If I put a 0, I wouldn't even see the colors. And then here I'm putting on the lines, the boundary lines, just to make sure I can see through. And here is my map. All right, so we can see that Chester W. Taylor Elementary had a B with 56% of points. And if I look through here, you'll notice that, let's see, like Wiregrass Elementary was an A, but it only got 70%. All right, so something about subject matter knowledge is that in the state of Florida, it only takes 64% of possible points to earn an A school rating. But you know, you can see there's plenty of C's, there's plenty of B's. So, you know, so when you look at, you know, school grades, when you look at the percent of total possible points, you need to have like that subject matter knowledge to know that 64 is the cutoff for an A. And if I look at the distribution across the state, that looks like a reasonable amount. Now, something that jumps out at us is we'll notice that we have a dark region here. This is for the Starkey Ranch K through 8 missing, or K through 8 school. It did not have a school grade. And you'll notice I have missing and then NA percent. All right, I left this the way it is intentionally. You'll notice that I have NA percent. Anytime I use base R string manipulation, a missing value will be converted to explicitly capital N, capital A. Now, if you use the string R package, it will do something that is not as dumb, but really I should have removed NA. If I knew about this before the video, I left it as an instructional point. But if I was to do this for work, I would want to go in and remove every time I have a missing value. So if I had comma space in a percentage, I would remove those from the labels before my client would see it. Now, another thing that jumps out at us is that we can see that Rodney B. Cox Elementary School was a D and it's labeled red, but not dark red. And so we can see that it got 36% of total possible points. So here, like this school got 42%. This one got 36. So, you know, there's a little bit of a difference. Looks like 42 is probably the lowest of the C schools. Yeah. All right, so now that is my categorical data. So I'm coloring by categorical data. If I want to go and make a more refined version, what I'm going to do this time is I'm going to change it to color by fill. So remember that in this tilde notation, I define a column called color grade, and then this tilde, Leaflet will know to look at the data frame, find the column called color grade, and use that where I'm explicitly calling the color. For numeric data, I do exactly the same thing. And we can see a little bit more nuance of the point range. So it's easier to see which school did the best, which did the worst, and which were in, you know, not too far off from the worst. All right, well, that's all I've got for you. Take care and goodbye.